Hello and welcome dear viewers to the video on wet granulation technology. In this video we are going to learn about the rapid mixer granulator. It is also known as high shear granulator and the technology is wet granulation. So there are various techniques for having the granules. So those technologies are direct compression, wet granulation and the dry granulation. Direct compression involves mixing of ingredients and compressing into tablet or filling into capsules. Wet granulation involves the use of solvent. Sometimes the binder is dissolved into the solvent and that binder composition is added. So it is called as wet granulation. The solvent used for granulation is called as granulating solvent, and that solvent may be aqueous like purified water or non-aqueous like organic solvents. For example, isopropyl alcohol, ethanol, acetone and EMDC. So different organic solvents are used. Then wet granulation can be performed in rapid mixer granulator and also in fluid bed processor. When the fluid bed processor is used, that granulation is called as top spray. And when RMG is used, that is known as RMG based wet granulation. Then dry granulation involves the roller compaction and slugging technique. Mainly the granulation is done to have the improved processability of the powders. The formulation are the mixture of API and the excipients. So to have processability, to have flow and require density for compression purpose and capsule filling purpose, the granulation is done. Granulation is also performed to have good flow, content uniformity, tablet properties and to have the processability for the composition. Wet granulation involves the use of solvents, so drying stage is involved. While in the dry granulation like direct compression and dry granulations using RC and slugging, these techniques doesn't involve the use of solvents and thus drying is not there. Wet granulation involves the use of solvent and the solvents may be aqueous, non-aqueous or hydroalcoholic. Wet granulation can be performed by using the RMG, FBP and PM. PM is planetary mixer. So these equipments can be used to perform the wet granulation. Then the tablet composition for wet granulation. Generalized tablet composition I have included here for your easy understanding. The composition contains API, that is drug substance, diluent, binder, disintegrant, glidant, lubricant, any other component or ingredient as required, like polymer for extended release type of formulation and coating materials. Coating may be film coating or maybe enteric, extended release or sugar coating. Dilutes like lactose, mannitol, dicalcium phosphate, MCC, starch and their combinations can be used. Binder like HPC, HPMC, povidone, copovidone, these are the generalized excipients used as binders. Disintegrant may be cross caramelose sodium, sodium starch glycolate, cross povidone and some others. Glidants like talc, colloidal silicon dioxide and lubricant like magnesium stearate, sodium stearyl fumarate and calcium stearate and others. So these make the composition. Then we will come to understand about what are the parts of RMG. Whenever we are going to use any machine or learn any machine, we should know its parts. So rapid mixer granulator is also known as high shear mixer. It has a bowl that contains the material or hold the material. You can see here it is a container. It is known as bowl. In this bowl there are two moving parts, impeller and the chopper. So impeller and chopper have their distinct functions. Impeller have the function of mixing and chopper have the action of breaking the lumps. Then discharge point will be there. That discharge point may be with or without co-mill. Impeller has the mixing action and its RPM is 25 to 200 and can be changed based on the requirement, and also it varies from equipment to equipment, and it is varied from equipment capacity to another equipment capacity. Chopper is required to break the lumps and its RPM is around 1440 to 2880 RPM. Always consider that there is no scale up in the chopper. Only impeller speed is considered while doing the scale up. So then we will understand about the working principle of RMG. As the name indicates, it is a rapid mixer granulator. So mixing happens in a short period of time. Mixing and densification is performed by the impeller and the chopper. So once you perform the shifting for raw materials and you put the raw materials inside the bowl of RMG and you start the machine, the impeller will start rotating and rolling action will be there by the impeller. The powder will start moving. So powder will experience the mixing action, and after starting the fluid addition or binder addition, the smaller powder particles will stick together with the binder with the help of binder under mixing mechanism, and their size will get enlarged. So this is the size enlargement activity. It is a mixing activity. Then the binder solution will connect the small particles together, and these small particles will again stick together to give the big particles, and this mechanism is called as binding or binder addition. So small powder particles will stick together and then the bigger balls will be formed. After the completion of binder addition, the dry powder will get wet. The dry powder will be converted into larger particles or lumps, or you can say as larger or enlarged granules. Then kneading action is performed, and in kneading the wet mass is to be distributed evenly. Kneading the wet mass to distribute the binder and for densification. Once you complete the addition of binder, then that material is required to be densified and mixed again. Also during kneading, chopper is started and that chopper breaks the bigger lumps so that the uniform size granules can be prepared. Granulation endpoint, that means when you can say that now the granules are formed. So during research phase, the trial and error methods are used to understand the endpoint. Optimization trials are taken, and based on that, the endpoint can be determined. So endpoint can be determined by manual like snowball test, and after having the data of scale up and exhibit batches, the amperage reading can be given. That amperage reading will control the granulation activity. Impellers mix the powder in dry state and wetting state with binder and solvent. This is called as dry mixing and wet mixing. Choppers break the lump into small granules and distribute the fluid added during binder addition. So this is the process of granulation. I am not going into much detail because it will extend the time of video. Now the steps for wet granulation. Shifting of raw materials, API and excipients, then dry mixing. Generally dry mixing is performed with impeller slow speed for a period of 10 to 15 minutes. Then granulation by binder addition and kneading and followed by drying. Then sizing and milling of the dried granules. Milling can be done by co-mill or multi-mill, or sometimes the oscillatory granulator is used. After that, blending and lubrication is performed. Blending is done with the dried granules and extragranular materials, and in lubrication, lubricants are used. Then once the lubricated blend is prepared, it is given to the compression department for compressing it into tablet, or capsule filling department for filling it into the empty capsules. Then if tablet formulation is there and if it requires coating, then coating is done, and after completion of the finished product, packaging activity is done. Packaging can be done by packing the batch into bottle, strips or blisters. So first step is the shifting of APIs. Particular sieves are taken as per the bulk density and particle size of the raw materials. Then dry mixing is done for 10 to 15 minutes with impeller slow speed and chopper off. Sometimes chopper is started if required. Granulation is done by binder addition by pump or by spray, and then kneading is done. Drying of wet granules in FBP or tray dryer. Shifting and sizing of granules, blending and lubrication. So after that you can go for compression or capsule filling. So in dry mixing you can take out the BU samples to ensure mixing. If the blend sample taken from dry mixing are not proper, then you can think to increase the dry mixing time. So sometimes for the formulations which contain very low dose, for those products BU samples can be taken from the dry mixing stage in RMG. These activities are performed in the scale up batches. Then binder addition. The binder may be dissolved in aqueous, non-aqueous or hydroalcoholic solvents. So it is added by peristaltic pump or spray in generally 3 to 5 minutes, and depends on the product requirement. You can add for more time also. Endpoint of binder addition is determined by physical observation, like checking the wetting and ball formation. Kneading is performed for wet mixing. The material which is there after binder addition. Kneading time is product dependent, and endpoint of kneading can be determined by observations and also by the amperage reading. So some observations are there which are required to be done when you are doing the uh, wet granulation by using the RMG. These are flow of material in dry mixing and granulation stage. So if your dry mix material is not flowing or not getting mixed, or it is sticking to the walls, maybe due to static or maybe due to some cohesiveness, so mixing will not be proper. That time racking can be done to improve the mixing. Then observe the lump formation, observe the local overweighting, observe the binder distribution. So these are some of the critical things which are required to be observed. Then input variables in wet granulation. What are the input variables? What are the input parameters? Those affect the weight granulation by RMG. So these are dry mix BD, dry mix material flow or movement inside the RMG bowl, and API to diluent ratio. Why I have considered here API to diluent ratio is because if API is very low and diluents are more, then probably you will need more mixing time. If API load is higher or medium, then mixing will be better. Fluid uptake. So fluid uptake is percentage of the dry mix. If you are taking a dry mix material, for example, say 100 kg, and you are adding 20 kg of the binder, so you can say that the batch is having 20% of the fluid uptake. Generally from 20 to 40% fluid uptake is taken, and fluid uptake depends on the composition. Then RMG occupancy. RMG occupancy is required to be calculated based on the bulk density of the dry mix material, and the occupancy should be fixed for scale up so that there will not be any surprise of mixing or demixing. Binder viscosity. Prepare the binder as dilute binder. Don't make it very viscous, because if you make the binder very viscous, that time the local dry mix material will come together and that binder will not get distributed properly. Binder addition technique, by pouring, by pump or by spray. So avoid pouring technique and use pump or spray the binder inside the RMG bowl. Then the input variables which are process dependent. Till now we have seen the dry mix BD and flow, binder viscosity, binder addition technique. All these are the composition related variables. Now the process related variables or critical process parameters, that is impeller speed, chopper speed, binder addition rate, kneading time, and the total granulation time. These are the variables for weight granulation. And these input material properties, CMAs and CPPs will affect onto the output variables or output CQs. So it affect on the granule properties, granule density, particle size distribution of granules, flow of granules or flow properties, then percentage of retention and percentage of fines. If fluid uptake is less, that time fines will be more. If fluid uptake is higher, that time there are chances of lump formation and the granules will be more. Then hard, dense or soft granules. So these are dependent on to the fluid uptake, granulation time and the binder viscosity. If you use high viscosity binder, then there are chances that you get the hard granules. Then loss on drying and moisture content of the granules. Blend flow, and all these variables will impact onto the tablet properties like weight variation. Improper flow will give rise to weight variation, hardness variation or hardness problem. LOD, if it is too low, then capping may be observed. So all the tablet compression parameters are driven through the granulation. Then disintegration and dissolution will get affected due to the granulation parameters. Then we will see the scale up of weight granulation. So tube speed calculation is done and fraud number is done. Calculation for tube speed and calculation for fraud number. So these two techniques are used for determining the impeller RPM for big scale RMG compared to the smaller scale RMG. So tip speed is calculated, and based on that tip speed you can keep the impeller RPM. Freud number is also calculated, and based on that you can go for the scale up batch. Here I have shown two pictures of one is tractor and another is two balls. So one ball is bigger and one is smaller. So consider it as a smaller batch and bigger batch. Here for generalized uh, understanding of T speed, here if you consider this bigger wheel and here it is smaller wheel, so these two wheels travels the same distance, but there is a huge difference in the RPM of two wheels. Small wheel rotate very fast while the big wheel rotate slower, and this is the mechanism of the speed, tip speed and float number. I will make a separate video on scale up of weight granulation. In that I will cover these points in detail. Then come to the advantages of weight granulation by RMG. As the name indicates that it is a high shear granulator or rapid mixer granulator. So the high quality mixing is there in the less time, and that's why the production rate is faster. If you consider the RMG granulation with top spray granulation, always you can understand or you can see that top spray granulation is time consuming. Then advantage is homogeneous granules, good mixing efficiency, dry mixing and wet mixing in a single place, easy operation and can be used for a variety of the products. So almost all the pharmaceutical companies which are working on to the oral formulations will have the weight, weight granulation equipment as RMG. Endpoint can be controlled based on the amperage reading if the batch size is same. So once you do the scale up batches, you have the data and then based on that amperage readings, granulation endpoint can be controlled. It is the most common and mostly used in oral solid formulations. And for weight granulation by RMG, scale up and technology transfer is comparatively easy after the direct compression method. Then cleaning is easy for RMG. Now RMG also have some limitations. That amount of the fluid to be added is limited. As the dry mix material has the capacity to take up the fluid quantity. Based on capacity, you can add the fluid. But if you correlate this with top spray granulator or FBP process, then you can add much more fluid as there is continuous drying process happening. But here the amount of fluid to be added is limited. Processing steps are required like drying and milling. Cost addition to the process. Overweighting or over granulation may lead to slower release because of the dense granules. Then dense and hard granules can lead to dissolution problem because dense granules will have the low porosity, and that's why the dissolution rate may be slower. Sometimes formation of big and hard lumps can occur, and sometimes improper binder distribution may be there, and because of all these you can get the granules or blend which is less compressible. If you correlate these things to the top spray granulation, then in top spray granulation you will have porous granules and will have the rapid dissolution rate for tablets made with top spray granulation. So these are the things which are important to understand for weight granulation using RMG. No doubt weight granulation is the process for almost 80% of the molecules. Weight granulation process is selected based on the API load into the formulation, API flow, and the other requirements. Sometimes API is required to be dissolved in the solvent like water or organic solvent, and then that solvent is added onto the dry mix. So by this method you can have the good distribution, good content uniformity, homogeneous blend, and also you can have the good dissolution as required. So I hope I have covered good understand. I have covered most of the topic for your understanding, and you can go through the other videos also for direct compression, and you can compare the direct compression versus wet granulation. Other videos will come for top spray granulation, and then in that video we will cover the comparison between three methods. So thank you for watching the video. Kindly do like, share and subscribe to this Paranormal Learning in Depth channel. Thank you.